Okay. So we have worked on the different kinds of things. So I gave some assignments on the savings bank and like bank loans, etc. So just walk through them. So, and you can solve because I gave the how to write in a theoretically. You just need to implement in program. So you need to use the variables to do it. That's it. So it would be very easy for you if you start working on it. So based upon these learnings, I just want to move ahead. So to something called as type conversions. So what are the different data types and how do you convert from one to another? For type conversions, I want to create a Jupyter notebook. So instead of .py, I write IPYNB. If I create, it will create an IPython notebook. See, the moment I created IPython notebook, it is giving everything in a cell-based fashion, right? That's what we have seen. So initially to say, what are the different data types in Python? So initially, if you don't know what is the cell, there are two types of cells. One is a code cell, other one is markdown, right? First, I want to write some theory. So markdown cell, I write like data type conversions. So is what I need to do in this particular program. This is a markdown syntax, just to write two hashes, that's it. And coming to the data types, in Python, we have at the basic level, int, float, complex, boolean, string, none. These were the very basic data types. Apart from that, there are 4 data structures which we'll learn afterwards. So the data structures also make use of these variables, these data types only. At the base level, these are the only data types we have. Then obviously, we will work on how do you work on these data types and convert from one to another. So first, I want to work on a code block. Say, I want to take a simple thing. Number is equal to some 12. If I tell number is equal to 12, see, for the first time when you execute any Python notebook, this kernel will start executing. So, and it will execute, see here. And if you ask number, it will say that it's a 12. And if you ask a type of number, it will tell what it is, right? So that's interesting thing. So I need not write it print built-in function because I am in an interactive mode. So now, if I want to convert that to a floating point value, so I can use a built-in function called as float. So for converting to float, so I can use instead of a number directly, I can use a variable also, right? However, I converted previously, the same way I converted here. So similarly, if I need to convert, say what I am writing in one line, I want to convert 12 to floating point value, I converted. In the same fashion, if I need to convert to a string, from integer to string, if I want to convert, say str is a built-in function. If I do str of 12, did you see the same 12 you got in quotes? It means it's a string. Similarly, so str of 12 means you got a string, right? In the same fashion, you can go for other conversions also. Say you initially you took a number which is an integer. Now let me take a number which is a float. Okay, if I take a float, then I want to convert. Say I have a float to string integer I want to convert. Float means let me take a 3.1416. This is a float, right? So if I want to convert, I can convert, right? If I give a floating point value, it will convert. If I give an integer also, it will convert. So means like whatever you give, you can convert, right? If I see in this example, if I have 3.1416, I am converting using int built-in function to integer. Using string built-in function, I can convert to a string. So one thing. Now one more thing, if you have a string is there now. If I have a string data type. Now if I want to convert anything to a string, if I have an integer and I can convert to a string using str built-in function, 12 I can take. And similarly, 12.3 I have, that also I can take. The beauty of string is that we can convert anything to a string. See, if I do these two, did you see you got two values? Similarly, if I say 12 str of the same 12 like a string, if it is there, then also it is a string, right? So we can convert 12.3 in a string. So we can convert. So anything, if you want to convert to a string, it is possible. Then if you ask that, hey sir, so can I do like 2? Can I convert that to a string? That is also fine. Because string is literally taking every character and doing, right? That is easy. But if you try doing the same things in other data types, that's where the problem comes. Say, if you want to convert, let's say there is a string. Now you want to convert back to the other data. Say, if you have a number like a string, say 12.3. Now, if I want to convert to an integer, right? That's where the problem comes. If I say int of 12.3, it will work. Whereas if I say int of 12.3, it will not work. So because so an integer can retrieve anything which is like a int only. Means if you give like a 12, it will convert, but not the other side. Then sir, how do you solve this problem? That's where we need to use something called as float. Float is another built-in function, as I told earlier, which will convert direct float numbers or integers or strings which have like a float. Like that also it can do. But at the same time, they cannot do if it's something like a garbage. Let's say if you do it 2, it cannot convert, right? Nothing can do except string, nothing can process them. Hope you now understood with some clarity. Now, at the same time, I told you a string is a built-in function which can convert anything to a string, but int, float, and all these things cannot convert everything. There is a limit, right? Just to give a clarity, I'm writing everything in one place. If we just write a float, it will create a float 0.0. If you give any number, it will convert. So minus also, and you give some slash and etc. That also it can process. Means don't give any other garbage. So only these kind of white spaces we call slash and slash are all these things. Those also it can verify and it can parse it. And if you give an exponential notation also, so like this also it works. And even if you can give infinity also it will work. So float will work on all these things. Sir, we processed all these things. Why we got only infinity? Because Jupyter Notebook, in each cell, it will print the last output if there were. You didn't write any print statement, right? That's why it's coming the last value. But everything was processed. So you can just try on your own and you can see. At the same time, the beauty of string operations is that string is a built-in function which can convert any data type to itself. As I told earlier, you see now, you give an integer, you give a float, you give a negative float, you give a boolean, you give a none. So do you see? Sir, everything is converted, but when I did earlier, when a string is coming, there are quotes, right? So whereas here, why? So there were no quotes coming. Because print, when there is a print, then it will remove the quotes. Hope you can understand. I repeat again, if I do the same str of 12 or like str of say none as above, did you notice there were quotes? Here also there were quotes, but print will actually remove the quotes. So nothing to worry about beyond that. So this is how it works. Okay, we worked briefly on all these data types. Again, coming to the integers. Integer family. Integer notations, I would say, notations. If you see, standard integers were of like any integer can be represented in 4 notations. So what are the 4 notations if you see? So an int can be represented in the decimal form, binary form, hexadecimal form, or octal form. Hope I need not give this kind of context. What are these? The way in which you represent, right? If you are representing a number with just 0 to 9, that is a base 10 decimals. If you are representing with 2 numbers, that is a 0 and 1, that is a binary. With hexadecimal means 0 to 9 and A to Z, A to F. And similarly, octal means 0 to 8. So this is how the notations will be there. Now, if you have a number, so how do you represent them in these notations? That's what very interesting. Say I have a number, say like I'm taking 23. I want to represent in first binary notation. You know what are the numbers we see? That is a binary a decimal notation by default. If I say binary, it is saying 0b because binaries will start with 0b followed by 10111 like that. But like how it is getting all these numbers? Hope you remember. So we have something called as you see, this is how I write, like, markdown logic. So you see, hope you remember this 8421 series. All were like powers of 2. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Like that, it will go on, right? That's a binary notation. If I take a number called as 23, how do you represent it? So it is which are is greater than that, which all will be zeros. So from there onwards, it will start. 23 can be represented with 16, right? Okay. After 16, what is left? 4 and 3, 7, right? So 0, 7, it cannot be represent. So 4, it will represent. And 3 is there like this. So don't you see that 10111? 10111. Don't you see we got exactly? So that is a binary format means. Say if I'm going for some other number, let's say I'm going for say binary of 9. So 0b 1001. So how do you process it? Let's say I'm starting with the 9. Whichever is less than that, it will be 0, 0, 0. If it is less than that, then it will represent 8. So after 8, only 1 is left, right? 0, 0, 1. So don't you see exactly we got the same? I'm just showing that, like, you will rememorize what you have learned earlier. This is not something new, but like just so revisiting what you know already. So the point is like, so when you combine all of them, the same value comes, right? That's what to say. Okay, that's how it works. So this is about binary notation. If you want to convert anything to binary, that is how we work. Say you have a binary now. Say you have a binary now. This binary number you want to convert to say decimal. You see, for converting a binary number to a decimal, you need to use a built-in function called as int again. See, anything if you want to convert to a decimal, you can use the int built-in function. So what are the number you have that you need to give? Because though it is an integer, binary form means it will be like a string. That's why we should pass the quotes. And apart from that, we should say what is the base. So here in base, there won't be 10, okay? If I say base 0, it means like, so the decimal, there won't be like base 10. So base 0, base 1, 2, base 8 like that for different notations. So just to give you a gist for you to understand, so of these things, what we have learned just now. So binary to decimal notations. So the same number what I gave in top and base 0, then you'll get 9. Similarly, if I just give, so 1001 also means 0b prepending is not there also, it will recognize like that, but it will give like this. You see, if you don't write this 0b, then it will treat it like an ordinary number and give it. It thinks like integer is in a string form and it gives it. That's why we should prepend the 0b. That's the importance. Even you can pass a built-in function, right? Like this bin also and get it. And similarly, there is one thing to tell, like if you have a number, say 9, if you convert to binary form, how many digits it could have. So if you want to know that, bit length is there. I never use this feature, but this is a feature which is there. In the same fashion, you can work with octal numbers too. If you want to convert anything to an octal, there is another built-in function called as octal, OCT. It will take any number and convert to the octal form. Hope it's clear. In the same fashion, same like here, octal. In the same fashion like this, there is one more thing called a hexadecimal also. Before going to the hexadecimal, we have a decimals, we convert it to octal. And vice versa, from octal to decimal also, we can convert. Again, using the int built-in function, base 8. You need to prevent the 0 else it will treat like an ordinary number. So that's what you should ensure. And in the final leg, we will go for the hexadecimals. So don't think that I'm going fast. Hope you can understand, right? This is what we have learned. I thought like hexadecimal means 0 to 9 and A to Z. So if you have a 9 or a minus 23, see how it is represented. If there were negative, negative is represented as is. See, 0x is prepended. For hexadecimal 0x, for octal 0o, and for binary 0b. That is a prepending will happen. In the same fashion, from hexadecimal, again back if you want to convert to decimals. So this is how you need to go. Hexadecimal you will take base 16, you convert it to integer like that. This is how it works. Similarly, there were like few more attributes within the for integers to work. There is something called as like a bit length. There is one more thing called as for any integer. See, observe carefully what I did. So I did like I didn't do like minus 2.0 dot is integer. So directly we can do, okay. It's crazy to understand, but it works like that, right? So seems like a dot going like that. That's why for you to understand, I wrote a brace around. Whether you place or not, it doesn't matter. So if I say like 2 also, 2 dot is integer. If I say 2 dot is integer, it's a syntax error. Means like for float, it is going directly. For integers, it is expecting a brace error. Int object don't have it. It is saying only float has it directly. So you are asking for an integer. So that's why. Means you gave it as an integer. Integer don't have. Only float has that attribute. Is integer or not? So is it a integer or not? That we can write. Integer means like round out. So 2.0 means round out, right? So 2.1 or 1.99, they are not rounded off. So like that. And similarly, not only this int built-in function is such an interesting thing that this int and floats. With int, you can convert. Hope you remember these were like Telugu characters. So, and you can convert them to, decimal form. These were like two Telugu, converts. These are not Rome numbers, like, so I would say these are Telugu numbers. Even Roman numbers also we can use. So all kinds of things. How I have extracted. So I can take this. So there were some characters. These were like numbers in Telugu. So these were like old script. So from that we can extract and get the numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all these things. If you want to do further in your own mother tongue and you do something, there is a table for that. You can extract the characters from there and you process. So hope it's clear till now for everyone. Is it clear? Can I go ahead?
Can you just elaborate the base, base 0 for decimal and other notation as well?
Yeah, simple. Decimal. 0 for decimal, so 2 for binary, 8 for octal.
Okay.
Sorry, octal, and 16 for hexadecimal.
Okay, got it. Thank you.
Okay. Similarly, now we will go for something called a K. So now we will go for something called as complex numbers. So what are the complex numbers? So I seldom used complex numbers again, but as it is there, I want to explain it about the complex numbers. So what is a complex number? Complex number is like a combination of real and imaginary value. So it can be plus or minus imaginary value. Real number means what are the numbers you are seeing till now? Integers or float, anything. Then what is the imaginary number? Any number which has a face to it. So it is a scientifically I'm telling, but simply to understand, if there is a j or a I along with the number, that is the imaginary part. In some places, imaginary is represented with I, some with j. In Python, it is represented with j, imaginary values. So means if I take a number, let's say number 1 is equal to something. If I ask to print, hey, what is the data type? You see, it is not printing anything because it is thinking it like a markdown object. Now see here, it is a markdown object. So I need to create a code object and execute it. Did you see? So number 1 is equal to 2 means it will process. As it's the first statement for this cell, kernel will start, and you saw it is an integer. Similarly, one more shot I use. Number 1 is equal to 2 plus 3. It is just an arithmetic operation. It will give 5 and the result is an integer. That is also true. Now let me go for one thing ahead. This time for the 3, I added a j at the end. Now you see what will happen? It is called as like a complex number. So complex number can be not only like that, I can have a 0 point so and so from 3 point so and so, means floating point values also we can have. Or now tell me this answer, very interesting. So I have it here as a 0j. Do you think it like a real number or else it's a complex number now? There is a 0j, right? Do you still think that it will be complex or a even real number? Even still it is a complex number. So that's how it works. So even yes, even if you just write minus 0.0 like that also, it will be complex.
Okay, so whatever the represented by j or
Yes,
whatever the number, it is the complex number, correct?
exactly.
Thank you.
At the same time, you need to understand that how this number is represented. We need to have a number which can be real, so int or a float or anything, and followed by j. This is the proper notation. And like you cannot use any other form. If you do like j4, it will think like j4 is a variable, right? So j should not come first. It will think like it's a variable and it is asking whether it is defined somewhere. Similarly, you cannot ask 4 into j. So both are multiplied like that means even then you cannot do like that. You can do 4 into 1j. J cannot exist individually. That's what you need to understand. Hope it's clear. Okay. So we cannot have, so conclusion is that we cannot have all these formats. In all these 3 formats, it will think j as a variable and it tries to work on it. Hope it's clear till now. So how you have worked on the complex numbers. Similarly, you can also create a complex number using a built-in function. If I say complex of 2, 3, did you see it created 2 plus 3j? I can assign to number 2 is equal to complex of minus 2, 3.4. And I can ask to print, hey, number 2 is equal to number 2, and hey, type the type of number 2. If I ask, it says minus 2 plus 3.4j. So which r is in the second place? That will become imaginary. And it's a complex, right? So you can create like this also. Next, so lastly, this is one of the interview questions which were asked. I am repeating to you. Hope you remember I earlier told that there were two equals. Till now you are using one equal. One equal means assignment. Two equals means check whether both sides are equal or not, right? That kind of check we can do with it. So what we can do, let's say 4 is there. If I say 4 equal to 4, don't you think that both are equal? Yes, both are equal. We cannot have like a 4 equal to 4. That will throw an error, right? You understood. You can use 1 equal to only for assignment. Assigning a value to a variable like that, but not like this. Okay, similarly, can I ask 4 equal to 4j? No. Neither 0 is not equal to, so 0j. So 0 is equal to 0j. Sure. So ultimately value is 0. So individual types, so they may be different, but like it how it works. Now one crazy interview question was asked sometime. So 3 plus 4j plus 4j, is it equal to, so 3j plus 4, or like I can write 4 plus 3j. Can both be equal? No. So because the total values you have, but real and imaginary both should be equal. So that's what you need to understand. So hope it's clear till now about the complex numbers. Okay, now you need to understand one interesting point. So I want to tell one another good thing called as Python is an object-oriented language. Object-oriented language means what? Everything is treated as an object, right? That's what we should understand. But like, where is the objects? Till now, we don't see a single class, right? So in fact, I got the same question in my starting day when I'm starting Python. So there was no classes till now, but how it works? Before even going, let's say, take a small example of an object. First of all, understand what is an object-oriented. Then we will see whether classes are really needed for it. So let's take an objects which are on your pen on a table. Say I am taking like pen. So don't you think like pen is one object? We can take like a pen as an object, right? Fine. So what is an object? How you are recognizing? By a particular shape, particular color, particular texture, and smell if needed. Like that, different objects has its own characteristics. So how you are recognizing with a shape and like a color and texture like that, right? In the same color and texture, the way it is working or something. And each object has a specific usages, right? Usage. In terms of usage, what is a pen used for? Either writing, so painting, so maybe like drawing. So what all can be? So what all use cases you can have? All of them you can do. Okay. So this is about a pen object. This is one object. Similarly, let's go for one more object called as a say cell phone is there on my table now. It is also an object. It also has a particular color, shape, texture, and others. That's how you are uniquely recognizing that object. Then what are the use cases of it? Of course, those are limitless, but still to make a list. So we can pictures with camera, so communication, alarm, watch. These are all the use cases of it. Now what I am trying to say here is that every object in the world is recognized in a particular way, and each has a particular usages, right? In the same fashion, when you execute also, same thing works. So in the object-oriented programming means, you should be able to recognize each one individually, and it should have a specific features like that. So similarly, any object-oriented programming will have three things which are the minimum. An address location where the object is stored. So it should be of a particular type, right? How much space we need to reserve. For that, the type should be knowing. So it's simple, like in a home, if there is a rice bag, where you will store? Will you store in like a cupboard or a big almirah? So if you have bought a pen, where you will store? In a big almirah or like a small cupboard? So based upon the type, you will go with a particular space, right? Like that. And it will have a value. So based upon the value, it will have a type and it will be stored in a particular location. So that's the reason every object minimum will have these three. And it will have some use cases also. So coming to the first thing, say I have taken a object called as number 1 is equal to say 2 plus 3j. I taken a number. I told that every object will have three things, right? What are they? Name, type, and address. So till now, if you want to get the value, that is what you are doing. And similarly, you are using type built-in function for getting the type. And in the same fashion, there is one more function called as ID. It will give the address location. What is the main purpose of ID means? To see the address. So address will be not like 1-2-2 or like a postcode. It is like memory address. So it will be like this. So I can list also like this for you to understand. Okay, now you understood these three things. At the same time, every object will have a usage, right? Python also in let's say this complex numbers has an usage. If you want to know the usage of anything, that's where dir built-in function comes to picture. Dir is a built-in function. If you apply on any data type, based upon the data type, it will give the usages. Usages means it gives very big things, right? But don't worry, we will not touch on the things which have underscores on either sides. Why I will tell shortly afterwards. But as of now, see which are not having underscores on either side. Only three, right? Conjugate, real, and image. These three are there. So we will touch base on these three only now. So for a number, these are called as attributes, not functions. What is the difference between an attribute and a function means? A function we will place around, right? Dir is a function, print is a function. Whereas an attribute we call with a dot. So number 1 dot real, number 1 dot imaginary, like that. So what is this doing? So real means it will give the real point. So real value, which is a 2.0. Means though it is an integer star means even then it will show 2.0 only, means float only. So imaginary, it will have a j within the number, but if you ask dot image, it will give a floating point value. In the same fashion, if you ask for the last attribute, which is a conjugate means whomever know complex numbers in math, they know that the same number we will get, but just the sign of the imaginary value will change. If we say -2 -3, same -2 plus 3 you will get. So what are the number you get? The same thing with a difference, that's it. Now, hope you remember the operator precedence, which I told. Operator precedence, right? There is something called as PEMDAS. So based upon PEMDAS, how it works. So let me give a small example. If I have like number 1, say I have number 1. Similarly, I have number 2. I will do. Say I will write number 1 equal to 2 plus 3j. Number 2 is equal to say 3 plus 3 minus 4j. Assume I wrote two numbers. Now the interesting part is if I say number 1 into number 2 dot real, what will happen? First number 2 dot real is happening, and that is multiplied by this. It is same like doing like this. You all know that parenthesis will be the highest preference, right? So attributes is much more preference, means after parenthesis, attribute has that preference. But in PEMDAS, we don't have that. So that's why I have gone and placed you the operator precedence further. If you just have arithmetic operations like this, but if you have further, you need to think like that. First parenthesis, different braces has their importance. After that, immediately you have attribute. You see, then you will see about indexing and others when you go down in your language. So attribute will have the second preference after parenthesis. So hope it's clear. And if you are doing like that and like this, it makes a lot of difference. If you want numbers to be multiplied first, so first you need to multiply and then do the real. So that is what you need to understand. Similarly, so hope it's clear. Any doubt till now?
Yeah, can you just repeat the conjugate function or?
Conjugate means if you have a number like 2 plus 3j, so you will get the conjugate means the same number, but like which change in the sign of the imaginary value.
Okay, only the sign, right?
Yes, that's
okay. Oh, thank you.
sure. So the next one is on the imaginary values. So sorry, after these things there is absolute. So there is a built-in function called as absolute. We will work on it shortly, so please rejoin.